All right, so we left off in the last video with basically having just spun up and deployed the Hello World sample application that comes along with the AWS SAM CLI and framework. So now we can switch gears and we can start implementing the functionality that I want to demonstrate for showing how to work with AWS S3 as a back-end data store for a serverless application model, or aka AWS SAM Java-based REST API. All right, so one of the great things about how we get these sample applications that come right along with the SAM CLI is that it shows us how to do a lot of really cool and interesting things by example. So what I can do with this is I can actually just run with the example here and refactor it, modify it so that it fits my use case. And so, well, the very first thing that I want to do is I want to add a new resource. And this is just, for the most part, generally just a straight up YAML style CloudFormation template. There are a few additional bells and whistles that are available or made available through the AWS SAM CLI, specifically this line, or AWS SAM framework, specifically this line right here. So the transform, and then AWS Serverless 2016 October 31st. But the key thing to always keep in mind here is, although there are some nice resources that are afforded, such as the AWS serverless function, you can still use regular CloudFormation in here, and it will work just as it would in a normal YAML-based CloudFormation template. So, since we're going to be working with the S3 backend store, then it makes sense to start our modifications by creating an S3 bucket. So I will call this my quotes bucket, will be the name of the resource. And then I just want to specify the type of my resource as AWS S3 and then bucket. And that's it. I'm going to let it auto-generate the name based off of the name of my resource, and then it will make sure it's unique, it being the CloudFormation technology within AWS. And then I can go ahead and just use this. Now, while I'm here, it's great that they gave me the hello world function and scaffolded out the directory structure, but I don't want to name everything the way they have. So hello world is great for an example, but we're going to write a real REST API here. So let me refactor some things and change the name of a few things. So I'm going to start by refactoring this project directory to, let's name it quotes API. And say refactor, okay. And then my hello world package, I don't really care for that. So we're going to change that to something else. So let's say the coding interface, and then quotes is now our base package. So I'll go ahead and click refactor there. And then, the name of this guy, let's change it up to, so my class, I'm going to rename my class to something, maybe create quote, like that. And then, so I'll need to, well, that's sort of a bummer. Normally this would update, I haven't told IntelliJ that this is actually a Java Maven project, which is why it's saying, hey, it doesn't know anything about JDK and all that other stuff. So let me come over here and make sure that translated through. So I'll update my package to the coding interface, and then what was it, quotes. And then I'll want to do that over here as well. So my default test, let me refactor this to the coding interface, and then quotes. of course I'll need to update the internal of this, the coding interface quotes. And this really only makes sense if it is create quote. However, I'm actually not going to, we're not going to write tests today. We'll be bad today. So let me undo renaming this. So app test, we'll keep it as app test. All right, and then over here in my palm.xml, let's make those updates there, and then we'll make IntelliJ know that this is a Maven Java project. So the coding interface dot quotes, and then quotes, I think like that. All right, so now if I right click on my palm.xml and I come down here and I said, all right, I want to add this as a Maven project, and we'll see it is now a Maven project, so it knows how to deal with, knows how to properly treat this as a Maven project. All right, so what have we done so far? We've added a new resource for an S3 bucket. We renamed some stuff, so let's rename the hello world function to quotes, or no, create quote function. And of course, this no longer lives in a hello world directory, it lives in a quotes API directory. And then the handler now maps to a package named the coding interface quotes, and then the class was create quote. All right, and we'll call this the quotes API rather than hello world, and then the base path is going to be quotes, and since this is going to be a creational thing, we'll use a post method. And I'm going to go ahead and get rid of these comments right here to external links. It is great that they're included, but they do get in the way a little bit, in my opinion. All right, is there any more? Yeah, there's one more. And there's probably another one down here as well. All right, so I'm going to change this now to quotes API for the output. And then I don't really care about exposing the ARN for that, or the ARN for the IAM role. Get rid of those. However, I would like to output the name of my S3 bucket, so I'm going to say, what was it, quotes bucket, and then the description is S3 bucket for quotes data store. I think that's one word, data store. And then value, I'm going to use the reference function to get the name of my quotes bucket in the output. Just like that. All right, very cool. I think I can now go ahead and start updating my create quotes class. And I never renamed that, so that needs to be create quote, just like that. Now it's no longer mad, which is great. And at this point, I think is what I want to do is I just want to update or build and deploy and make sure that these updates do still function and I don't have any breaks that need to be fixed. So let me come down here, oops, and I will do a SAM build once again, and fingers crossed this will build. All right, looks like it built, and now I can do a SAM deploy. And if this deploys, I should be able to make a post request to my API endpoint. Well, with the one caveat that don't want that portion anymore, so I'll have to remember to remove that when I make the request, because we now map to quotes. So once this deploys, what I'll do is I'll make a post request to our REST API endpoint. And of course, it's not going to really create anything or save any data. And I will still just get back my hello world message and a location of Adam's house. But that will tell me that everything built and deployed with the refactor changes that I put into play there to refactor from the base sample hello world application to a more properly named project with quotes API as a source directory, updated class name, updated package, and everything else that we saw there. All right, so it looked like that deployed. And so what I'm going to do is I like the HTTP HTTP client for the CLI. There are others out there like curl and whatnot. I'm a big fan of HTTP, so I use it in place of things like curl or Postman or whatever else you like to use. So if you want to use HTTP, go ahead and install that with Brew or whatever other mechanism you use to install software with, or use your favorite tool. But I will do a post to that endpoint, however, not hello, but quotes. And hopefully what we'll see is a response, right? So we got hello world and then Adam's house. That's great. That means we didn't break anything terribly bad. So now the next important thing to do is I need to start pulling in other portions of the AWS Java SDK, which will allow me to use call the S3 service and use it as a backend data store. So as of right now, we have the Java AWS SDK for version 1. A few years back, they started rolling out a version 2 of the Java SDK. And there's sort of this weird in-between state where some things haven't quite been ported to the version 2 SDK quite yet, while many other things have. So what you often find in Java projects in AWS that are heavily integrated with AWS services is a mixture of the two SDKs, which AWS does make relatively easy to deal with as long as you're using something like Maven or Gradle. So we're using Maven, so what I'll do is I'm going to add this new section in right here for dependency management. And this is going to specify that, hey, I want the version 1 AWS SDK bill of materials, and then I also want the version 2 SDK. And then down here, you can see I've already got a couple of imports for Lambda-based resources from the version 1 SDK, and now I'll start adding in more dependencies to work with S3 specifically. So I have a couple over here off to the side that I can grab and then paste in, and I've got those. So I'm going to come down here underneath this last JUnit one, and I'll paste in these others. And so the first thing I'm doing is I'm pulling in the S3 module, and I'm telling it that I don't want certain portions of it, just because you want to have your Lambda functions have as few library dependencies in them so that your startup time is as fast as possible. You don't have any extra baggage with unused code, so code in your libraries that you're not actually using. So I'm saying, hey, I don't need these two. I don't need the Apache client, and I don't need the Netty client as well. But I do want the URL connection client. And we're also going to work with JSON serializable data structures, and a good lightweight client library for that is the JSON library from Google. So I'm going to pull that in as a dependency as well. And then I'm going to click the reload button here in my Maven project so that it pulls in and indexes those libraries that I just added in. All right, so I've now updated my Maven Palm with the necessary additional libraries and dependencies. All right, very, very cool. So let's actually start saving data to S3, shall we? So I've got this create quote class that implements the request handler interface from the API, or from the Lambda API gateway library code. So, what I think I'll do is I'm going to start by adding a new class, or actually an interface, and I'm going to name this interface quotes repository. And my quotes repository is going to have a handful of abstract unimplemented methods as the contract for interacting with my backend data source, which again is S3. But if we ever want to switch that out for something like, say, a relational database or a NoSQL database, this will allow us some additional flexibility. So it's always a good idea to program to an interface. So we will follow that. And off the bat, I'm going to work with optionals, and we're going to work with a POJO called named a quote. So we'll create that in just a moment here, but I want to start by scaffolding out a few reasonable methods. So we'll say we're going to work with a save quote method, and it's going to take a quote. And then we're also going to work with a list quote method, which lists quotes. Let's just say list. And then we're also going to work with a one that gets a single quote, so optional of quote. And this is going to be get. And we're going to say we're going to get something by an ID. And then we're also going to have a Boolean returning method, which is delete. And that's going to delete a quote by ID. And so that's our interface. Before I go any further, let me go ahead and create this quote POJO class. So quote, and my quote POJO is going to have a few fields in it. It will have a private string ID, a private string author of the quote, a private string the message of the quote itself, and then we're going to be good stewards of the web, and we're going to say a private string source URL, so where I get this information from, where we pull the quote from the web. All right, so let's go ahead and generate a constructor, and we'll have it an all args constructor. And of course I could use something like Lombok, but I want to keep my Lambda function as light as possible. I don't want to pull in any additional code, so I'm not going to pull in Lombok just for that. But I do want getters and setters, so we want getters for everything. And then, I wanted that to be getters and setters, and I only clicked getters. So let me erase that, and I'll say, give me getters and setters, all my fields there. And then I always like to, well, it's going to be particularly important for this demo, but I generally always will add a equals and hash code as well, and I like the Java 7 Plus edition or version of those, and I want to have all of my fields. Is that true? We'll leave out the ID field, I think, actually. Let's leave out the ID field. And everything else, and none of these can be null. All right, So now I have a hash code and an equals override implementation as well. Cool. I have 3 problems. What are my 3 problems? That's actually really not a problem. That's fine. All right, so I'll close that. And the issue over here is that I never imported these classes. All right, so that's fine. So let me add an implementation class now from my repository, and I'm going to call it, let's say, quotes S3 repository, and that's going to implement quotes repository. And come over here, and I'm going to say implement my methods. There we go. That just scaffolds it out for us. Very cool, making great progress. All right, so let me go back over to my implementation class here for the Lambda handler itself. And we'll start putting this to good use. All right, so obviously if we are going to save data to S3, then I'm going to need to know the name of my S3 bucket. So what I can do here is see how it gives an example of how we can inject environment variables into our Java source function. What I'm going to do is I'm going to change that out for an S3 bucket, and that's going to be the name of my S3 bucket, which I can use the ref function to reference this resource right here. And so that way, I now have an environment variable within my Lambda function, and we're going to call it quotes bucket, not S3 bucket. Let's call it quotes bucket, so I'm more specific. And then that gives me access to the name of my quotes S3 bucket within my Java function here. And so, I need to make my repository aware of my S3 bucket as well. So if I come over to my quotes repository implementation class, then I'm going to add a field for private string bucket name. So this will hold the name of my S3 bucket. And I'm also going to, let's make these final actually. Let's make them immutable. So I'll do private final string S3 bucket, and then I'll also do a private final S3 client. So we'll create a client, and it's going to be called S3 client. And then I also want to give it access to a logger. And so Lambda has a specific implementation of a logger, so we'll just use that one. So let me say private final Lambda logger. That's going to be logger. So of course now I want constructor for my quotes S3 repository. And you know what? I could have just generated that, which I think is the better approach. So let me go generate a constructor, and all those fields are great. So we're not actually going to construct the S3 client, or we're actually going to construct the S3 client. And that's going to be constructed with a builder class provided by the S3 library in the AWS SDK. So let's say S3 client and then builder, and that's going to require the region. And the cool thing about Lambda is it's always going to be injected an environment variable named AWS region. So I can use that to specify the region. However, there is a region enum within the SDK that I want to use to help me pick the right one. So let me import that, and then I'll use system get-env to pull out the environment variable for AWS region like that. And then I also need to give it a HTTP client builder. So this is what it's going to use to make HTTP requests to the AWS S3 REST API. So let's say HTTP client builder, and that client builder is going to be provided by URL connection HTTP client builder. And last but not least, I call build. And that creates a client for this class. All right, back over here. So let's start putting this repository implementation to use. And I will start by doing we'll say var quotes repo equal to a new quotes S3 repository. And so that's going to take as the first parameter the bucket name, and then we'll give it the logger. So remember, we injected the bucket name as an environment variable, and that was quotes bucket was the name of the environment variable. So we got quotes bucket being fetched out of the environment, and then I'm going to give it the logger. So there's this context field of the request handler method that I can use to access the Lambda logger. So if I do context get logger, that's going to pass the logger down into my quotes repository. All right, and then I don't really like how verbose this map is here for the headers, so I'm going to make my own version of this, and it's going to look something like this. So I'm going to come down here, and this is just sort of my own pedantic thing, but I like concise code. So I'll say map of, and I will steal those two lines, and then on a new line I'll set the other headers to look like that, and there. Now that's much more concise. I can get rid of those three lines, and they will just take one extra line down here instead. All right, cool. So this post request, so it handles a post, and then the body is going to be the fields of my quote, right? So that means I'll have author, and that's a string, and then what was it? Message was a string, and then source URL, of course that's a string as well. So that's what we expect to handle here. And we're going to serialize that into our quotes POJO. Well, we're going to use JSON for that, the Google-based JSON serialization library. So let's do var JSON equals new JSON. And then down here, we'll do a try catch in case we throw a JSON serialization exception. And JSON syntax exception E. And then that means we're going to use JSON, and we're going to say from JSON. And we can get the body of that post from this input API gateway proxy request event for the first parameter of the request handler. So I will utilize that and say input get body. And then of course I need to give the quote class as the basic template for how it should deserialize that incoming post request body. Now I'm going to use my quotes repo to say save quote. Right, so thus far I have var quote equal to that, which I guess I don't really need to make a whole new variable for. I can just give it to it like that. And then we know the response for this is an optional of a quote. So let's say optional quote result equals that. All right, so we've now used the save method to save the incoming post body serialized to the quote class with the JSON library. At that point in time, we'll interrogate or inspect the result. So let's say if result is empty, then we know something terrible happened. It didn't save correctly to S3, and in which case we would return response. Looks like I need to pull response up here at the top. And I don't like the verbosity of having both sides of that like that, so we'll use the var declaration there. And now I can say response with status code, and I'll use the HTTP URL connection with its enums and say, hey, there was an HTTP internal server error, because for whatever reason we couldn't save it, right? Otherwise, let's return a response with status code of HTTP connection URL of HTTP created. And then with body, let's use JSON once again. So we'll use JSON to JSON this time. And that's going to be result get, so the quote that was saved. Something like that. Now, in the event that we threw a serialization exception because we had bad input posted to us, let's handle that. So first thing I want to do is I want to say context get logger, and I'll log that something terrible happened. So I'll just, the most likely thing is I got bad input, and I'll just say input get body, so that we get that in the logs captured, and then I'll return a response with a status code, obviously of something like bad request. So we'll use HTTP bad request, like that. And then we don't need the leftover that was at the bottom there. All right, so what remains now is we just implement the save, right? So if we come over here and we go to save, right now it's just returning an empty optional. So let's see how we can save data to S3 using Java. So the S3 library for the AWS SDK follows a specific pattern pretty much in all of its operations, where you create a request object and then you use that request object with an actual call to the REST API. So let's say var request equals put object request builder. So the AWS Java SDK uses the builder pattern very heavily, which isn't a bad thing at all if you ask me. But so the bucket name, we have a field here for bucket name, so we can use that to specify the bucket name. And then we need to specify the key to this, which we're going to create here in just a second, and then we'll make a build. So I want to do something very specific with the field of, or the key of my S3 object. And if you're not familiar with S3 and the way it saves things, is every object is saved according to a specific URL, right? So you'll generally have like bucket name, so the name of the bucket, and then you'll have a / and then path to object, and then whatever file extension, if you're using a file extension, we'll use JSON. So in our case, bucket name, right, is coming from the creation of our S3 bucket in the CloudFormation template. And then this remaining portion here is called the key for your object. And so I want our key to follow the pattern of author and then quote hash code .json. And so I need to implement like a helper method that constructs this portion of it. And so like the author, we need to make sure is URL compliant, so it has no spaces and that sort of thing. So it's kind of like slugifying it. And so, like I said, what I'll do is I'll make a couple of helper methods. And so I'll start by saying So it's going to return a string, and it's going to be author. The name of this method is author name to S3 prefix, and it's going to take a quote. So we'll say quote is the parameter to the method, and then I'm going to take the quote object, and I'm going to get the author, and then I'll put it into lowercase, so it sort of normalizes it, and then I'm going to replace all instances of a space, so white space, and I'm going to replace that with a dash. And so that's what that's going to do. And then I'll have a the remaining portion is to use the hash code of the quote Pojo class itself. So where was that at? Right here. So we'll call hash code, and we'll just get the numeric hash of the object contents, and we'll use that as the file name. So let me come down here, and let me say string is going to be the return, and we're going to say quote to S3 key. And this is going to take a quote again, so quote. And then we'll say var prefix. I was going to use the method that we just created above, so author name to S3 prefix. We'll pass it in the quote, and so that'll give us the author portion of the prefix. And now we'll get the file name portion, right? So file name equals string format. We'll say %s.json, and this is going to be quote hash code. There's our prefix and file name. So now we just need to return them combined. So string format, it's going to be %s / and then %s. And that is, of course, prefix followed by the file name. So that looks like, if I'm the author, if Adam McQuiston was the person making the quote, and then maybe the quote hashed out to like 11223344 as the hash code, and then .json is essentially what that would return. All right, so let's use that. Save quote right there. So I can say quote set ID, because we're going to set the key to be the ID here. And so that's going to be quote to S3 key, and then we give it the quote, which means I can now say quote get ID, and then so that will be our key. So author / hash code .json will be the key / ID, same difference. All right, so we've constructed the request. Now let's call put object on our S3 client. So let's do S3 client put object, and then the request, and then the data, which we need to get the data. So we'll use good old JSON again. So let me create an instance of the JSON class, new JSON. All right, and then we'll say JSON is equal to JSON to JSON, and that's going to be given our quote object, right? So now we can use that JSON string as the data to be saved in S3. So let's say request body from string JSON. Now this could theoretically throw an exception. We are making network requests, so let's be very safe and wrap it all in a try catch. And let's just catch the base exception. Not the best practice, but it is very safe nonetheless. So log failed to save quote, and then let's say logger log e get message. And of course, if we're doing something bad like that, then we also need to return optional empty, signifying that we didn't save anything. Otherwise, we can put our code in there in the try block, and we'll return optional of our quote, signifying that we saved it. All right, so that looks pretty good to me. I bet that should work. Yes, that should probably work. So let me go back to our template, make sure we are mapping back to the right request handler, create quote class. That all looks good to me. So let's build and deploy. All right. Oh, there's one thing I realized that we didn't do. So I need to give this Lambda function permissions so that it can save and read and update and delete data from S3. So I can add a new field to the create quote resource of policies, and the AWS SAM spec provides these great policies. So if I pull over my browser again, I'll just research AWS SAM reference, and then I come over here to the docs, and I cruise down here to policy templates. There's all these wonderful policy templates that make writing IAM policies for our Lambda execution rules a lot easier. And within there is S3 CRUD policy. And so these are all the different actions, so CRUD for create, read, update, and delete, that we can do on an S3 bucket as long as we specify the name. So the name of this is S3 CRUD policy. So let me come back over here, and policies are an array. So I say, give me the S3 CRUD policy, and the bucket name that this policy needs to be given to is my quotes bucket. All right. So now my Lambda function has the correct permissions. Let me build and deploy this thing. So SAM build. All right, now I deploy. So SAM deploy. All right, it's creating the change set. You can see all the updates that are going to happen. So it's creating IAM rules. So the member that was specified with this policies directive for my AWS Lambda function. So those policies are going to get attached to that rule, and that's my execution rule. All right, now we have deployed it. So let me use HTTP PI to make a post request to our endpoint. And I've got a handful of quotes that I stole from the internet here. And the first one is Donald Kooth, and his quote is that premature optimization is the root of all evil. I love that quote. I think it's very applicable. So let me come down here and we say message equals that. And then of course I have author next. So author is Donald Kooth, and then the source URL from where I found this on the web is that. So source URL equals that. And hopefully I didn't miss anything, but I'll post that up. And we'll wait here and wait for our Lambda function to get spun up and execute. We got an internal server error. So something bad happened. That's okay. Let's use SAM logs to find out what bad thing happened. So I'll do SAM logs and then stack name. And I can find my stack name from the last time I deployed. So that was this guy right here. And then the name of the function is this guy right here. And then remember, I'm using a specific profile here, which is account A in my case. And then the region was US East 2. And I'll call tail on that. And interesting, I don't see an error in the logs. So that makes my job a little bit harder. Let me look at this request again. So message, author, source URL, repost that. All right, still an internal server error. Let me look at logs again. Maybe I just didn't capture it in the logs the first time. Don't see an error in the logs. Maybe I have some sort of logic error in this function. I have this flipped. Okay, so only if if I get an empty response, then I'm thinking there's an error. So right now I have, if not empty, that means we did something wrong. But we want to get rid of that negation operator. So if it is empty, then that means it didn't properly save and we respond with an error. Otherwise, it's not empty and we go down to this section of code and we return a success. So the problem is I just had a logic error there. I didn't actually have like a syntax or some sort of other error. So I will go ahead and build that again with that quick fix, redeploy, and this time we should see a successful 201 created response. So let me do a deploy. And this should deploy fairly quickly because it's a pretty small change. All right, let's try that post request once again. Didn't mean to click that link, but so repost the same quote. Hopefully this time we see a 201 response rather than an internal server error. All right, and right on. So this saved. I could prove that by looking at the data in my S3 bucket as well. So there's the name of my S3 bucket. Let me just interrogate that. So I'll use my AWS CLI for that. ls S3, and then let's throw a recursive on there. Profile account A, region US East 2. And there we go. We see our Donald Guth quote. All right, I realized that lecture got quite a bit longer than what I really wanted to, so I think I'll stop there and continue on in the next lecture or the next video, how to fetch data back out of S3 using another endpoint for this serverless REST API. I hope you found what we did here interesting, and if you have the time, please join me in the next video. Thank you.